All right, so Bo asked this question over 2 years ago, but no one answered it, so I thought I'd give it a shot in case anyone comes across this question and wants to know how it's done. So we are given the formula or equation of an ellipse, which I've written out here because it looks a little bit nicer. And we're also given points P and Q, given as a cosine theta, b sine theta, and a cosine phi, b sine phi. We're asked to find the equation of the chord PQ. Now remember, a chord is a line segment between 2 points, as I have shown down here. But for our purposes, we're trying to find the equation of the line PQ, because we know how to find the equation of a line. We're going to have to use the formula for slope, which I have right here, y2 minus y1 over x2 minus x1. And we can also use one of the useful equations we can use is point slope. Y minus y1 equals m times x minus x1. Because if we have the slope, we can just plug that in there and then use one of our points, x1 and y1. So I'm going to call for point P, that is x1, y1. And let's call point Q x2. Oops, 2 is a little messed up there. And y2. Okay, but what makes this problem harder is that we're not asked to find any equation of the line. We're asked to find a very specific form of that equation. And it seems like, okay, if we just find the slope by plugging in the x2, y2, x1, y1 of these points into the slope formula, and then plugging that slope into the point slope formula, then we have the equation of a line. But we have to take a few extra steps to match it to this exact equation. And so on the next few tabs, I'm going to show you all the steps in full detail of how you can do that. So starting with our equation of the ellipse, and now you're going to see me use A and B here. I put in values. This is because I took it from Desmos. And also you're going to see that instead of theta and I think it was phi, I'm using alpha and beta as my angles. So first I defined point P and I defined point Q. I gave them values because I had to in Desmos. Okay. Now, I said earlier that we're using point slope. And so we have the point slope form right here using point P, but I haven't put in M yet because M, our slope, looks like this. B sine beta minus B sine alpha divided by A cosine beta minus A cosine alpha. And that looks pretty rough, but we're going to actually clean it up a little bit by using one of our trig identities, which I have in this tab. Notice we have the difference of 2 sines and then the difference of 2 cosines, and that is our sum to product, really difference to product. So we're going to be using the difference of sines and the difference of cosines to this board, rearrange our slope into this. And we can simplify this because we can cancel out a common factor on the top and bottom. We can also cancel out the 2's here and here. And now we can plug that slope back into our point slope formula. But we're not done yet because we're going to need to multiply the denominator to both sides and then distribute to get this is the left-hand side. And then we're also going to distribute this right-hand side, distribute this b cosine alpha plus beta over 2 to both the x and the a cosine alpha. And when we've done that, we'll have this. Now, what we're going to do is collect the AB terms on one side of the equation and collect the x and y terms on the other side. Okay. Next, we're going to divide both sides by AB. This is to get rid of the AB on the left-hand side. And on the right-hand side, we're going to have x over a in front of the cosine term and y over b in front of the sine term. And that's good because in the original question, it asks us to have it in that form, x over a and y over b. So the right-hand side is basically done. But that left-hand side, we have sine, sine, cosine, cosine. We should recognize that as another trig identity. Specifically, it's going to be the difference of angles. It's going to be this bottom one here, cosine of x minus y. Now they have cosine, cosine, sine, sine first, but the order doesn't matter. So this sine, sine, cosine, cosine is really going to turn into cosine of the difference between those two angles, our angles being alpha and alpha plus beta over 2. And when we subtract those angles, making the denominators the same at first, 2a over 2, 2 alpha over 2, I should say, we'll get that this becomes the cosine of alpha minus beta over 2. Now, if I plug that in or replace the whole left-hand side with just cosine of alpha minus beta over 2, I will get the equation cosine of alpha minus beta over 2 equals x over a, cosine alpha plus beta over 2, plus y over b, sine alpha plus beta over 2. Now, I added this restriction right here just so it actually represents that specific line segment, but that's an optional step because the question asks us to find this specific form, and we've just done that. So there's a lot of steps to this problem. It starts off with just using slope and point slope form. Simply writing that or plugging those values in isn't enough because it wants us to go the extra simplification steps, which used these 3 trig identities. All right. Hope you found that helpful. If anyone is still looking for the answer to that problem, that's how you'd solve it, and I'll see you in the next video.